find this video helpful, please like, subscribe and press the bell icon for notifications. So guys, this video is a quick review of basic concepts of matrix. A matrix is a collection of numbers arranged in row and column form, and it is denoted by a capital letter like capital A, B, C, etc. For example, a matrix A with 2 rows and 3 columns is represented as capital A, that is for matrix, is equal square bracket. So all rows and columns are enclosed in this square brackets. We have 3 columns C1, C2, C3 and 2 rows R1 and R2, and these dots represent numbers in the form of rows and column. Now let's replace these dots with numbers, and let's take 2, 1, 3, 0, 1, 2. So this is row 1, this is row 2, then column 1, column 2 and column 3. Now if M represent number of rows and N represents number of columns, then the matrix A is equal 2, 1, 3, 0, 1, 2 is of the order of M into N. So M is number of rows and N for number of columns. So this will tell us how many rows and how many columns we have for a matrix. So here we have 2 rows and 3 columns, and we write order of matrix at the bottom right corner. Now the position of 2 is in first row and first column. 1 is in first row and second column. 3 is in first row and third column. 0 is in second row and first column. 1 is in second row, second column, and 2 is in second row and third column. Therefore, number of elements in a matrix is M times N. Means number of rows times number of columns will give us the total number of elements in that matrix. So in this matrix, we have 3 rows and 3 columns. So it's a 3 by 3 matrix, and if we multiply M with N, we will get 3 times 3 is equals to 9. So there are 9 elements in this matrix, and this type of matrix is called square matrix, where M number of rows and number of columns are equal. So this is of the form of M is equals to N. Now let's write down a matrix of M rows and N columns. Our first row is A11, A12, A13 up to A1N. Similarly, we can write couple of more rows before writing down our last row, that is mth row. Therefore, mth row will be AM1, AM2, AM3 until AMN. Now let's take any column J. So therefore jth column will be A1J, A2J, A3J until AMJ. Now similarly take the ith row and fill it out with AI1, AI2, AI3, AIJ, A, I, N, and complete the jth column with A, M, J. So we can write A as Aij with order M into N, and I is greater than or equal to 1 and less than or equal to M, and J is greater than equal to 1 and less than equal to N, and I and J, they belongs to natural number, and they tell us the position of an element in the matrix. So if it's A2, 3, it means that element is in second row and third column, and so on. Now let's talk about the types of matrix. So our first type is square matrix, and a square matrix is a matrix when number of rows is equal to the number of columns, that is M is equals to N. So like in this matrix, A1, A11, A12, A13, and 21, 22, 23, 31, 32, 33. This is of the type, the order 3 by 3. So there are 3 rows and 3 columns. So M is equals to N here. So it's a square matrix. Now a second one is rectangular matrix. So rectangle matrix can be formed in 2 ways. One, if number of rows are more than number of columns, that is M is greater than N, then it will form more like vertical rectangle. So like in this matrix, number of rows are 4 and number of columns are 2. So number of rows are greater than number of columns. So this will form more like vertical rectangular matrix. And if number of columns are more than number of rows, then it will form more horizontally stretched rectangular matrix. So like in this matrix, there are 2 rows and 4 columns. So columns are more than rows, so it will form horizontally stretched rectangle where M is less than N. Now the row matrix. So in row matrix, we have only one row, that is M is equals to 1 here. So number of rows are 1 here. So a matrix of the type A11, A12, A13 until A1n is a row matrix, and its order is 1 times n. So M is 1 here. Now for column matrix we will have only one column, that is n is equals to 1 here. So like the matrix A11, A21, A31 up to AM1, and it is of the order of M times 1. So n is 1 here. So this is a column matrix. Now the diagonal matrix. So diagonal matrix is a square matrix when its all non-diagonal elements are 0. So except diagonal one, all other elements are 0 here. So a matrix of the type A11, 0, 0, and all the diagonal part will be non-zero here. So it will be 0, 0, 0, 0, but here A22, A33. And it's of the type M into M, or 3 times 3. Therefore, we can say that Aij is equals to 0 if j is not equals to I, or I is not equals to z. And if I is equals to j, that is the diagonal part where it is non-zero. Now identity matrix. So identity matrix is a square matrix with all diagonal entries equal to 1 and non-diagonal entries are 0. So the matrix of the type 1 0 0 0 1 0 0 0 1 or 1 0 0 1 or 1, so in all cases diagonal entries are 1 and non-diagonal entries are 0. So this is identity matrix where A11, A22, A33 all are equal to 1. Now scalar matrix. A scalar matrix is a square matrix where all the diagonal entries are equal and non-diagonal entries are 0. So the matrix of the types A00, 0A0, 00A or 2002, in both cases diagonal entries are same, they are equal. Therefore Aij is equals to A when I is equals to j, and Aij is equals to 0 when I is not equal to j. So like here, all the diagonal entries have equal I and j. So now eighth one is zero matrix. So zero matrix or null matrix is a matrix where all the elements are 0. So like the matrix of the types 0 0 0 0 0 0 0 0 0 or 0 0 0 0, single column with zeros, then 3 rows and 2 columns with zeros, and single row with zeros. So all are null matrix. Now equal matrix. So two matrices can be equal if and only if they are of the same order. Means order of A should be equals to order of matrix B. So if matrix A is 2 3 1 0 and matrix B is 2 3 1 0, so they both have the same order, so they are equal if their corresponding elements are equal. And here 2 is equals to 2, 3 is 3, 1 is 1 and 0 is 0. So all their corresponding elements are equal and these two matrices are of same order. Therefore A is equals to B. So let's take one more example where matrix A is equals to 2 3 1 0 and matrix B is equals to 2 3 5 1 0 4. And as we can see that matrix A is of order 2 by 2 and B is of order 2 by 3, which are not equal. So therefore matrix A cannot be equal to matrix B, and also there are no corresponding elements for 5 and 4 in B, so they are not equal matrix. Now let's take one more example where A is a column matrix XYZ and B is also a column matrix minus 1 0 1. So if A is equals to B, then we can write matrix XYZ is equals to matrix minus 1 0 1. Now the corresponding values are x is equal to minus 1, y is equals to 0 and z is equals to 1. So we can write x is equals to minus 1, y is equals to 0 and z is equals to 1 here. Now let's do addition. For addition again, matrices should be of same order. So let matrix A is equals to 2 1 0 3 4 1 2 2 2 and matrix B is equals to 1 2 1 1 1 1 2 0 1. Now add their corresponding elements. So corresponding element for 2 is 1, for 1 is 2 and for 0 it's 1. So just add each of the corresponding elements. So it will be 2 plus 1, 1 plus 2, 0 plus 1 and similarly 3 plus 1, 4 plus 1, 1 plus 1 and 2 plus 2, 2 plus 0 and 2 plus 1 which will give us 3, 3, 1, 3, 4, 5, 2, 4, 2, 3. Similarly, we can do subtraction too. Now let's do multiplication and multiply by a scalar first. So if a matrix A is equal to A11, A12, A13 and A21, 2, 2, 2, 3 and C be any scalar, then C times A will be C times matrix A11, A12, A13, A21, A22, A23. Now this scalar quantity C will be multiplied with each and every element of matrix A. So we will get CA11, CA12, CA13 then until CA23. Now let's take an example where A is equals to 2, 4, 6, 5, 1, 0 and 3, 2, 1 and C is equals to 2. Then CA will be twice of A, that is 2 times 2, 4, 6, 5, 1, 0, 3, 2, 1. Then multiply 2 with each and every element of matrix A. Then we will get 2 times 2, 2 times 4, 2 times 6, 2 times 5, 2 times 1, 2 times 0, 2 times 3, 2 times 2, 2 times 1, which will be 4, 6, 12, 10, 2, 0, 6, 4, 2. Now let's do multiplication. So for multiplication of two matrices, number of columns of A should be equal to number of rows of B. Then only multiplication is possible. So if number of columns of A is equal to number of rows of B, then only we can do multiplication. Now let matrix A is equals to 2, 0, 1 and 3, 1, 2 and matrix B is equals to 2, 0, 1, 1, 1, 3. Then matrix A is of order 2 by 3 and matrix B is of order 3 by 2. Then we can clearly see that number of columns of A is equals to number of rows of B. Therefore, we can multiply these two matrices and the product of A and B will be of order 2 by 2. Now let's multiply matrix A is equal to 2, 0, 1, 3, 1, 2 and matrix B is equal to 2, 0, 1, 1, 1, 3 and then A times B will be 2, 0, 1, 3, 1, 2 times 2, 0, 1, 1, 1, 3. Now to multiply this, let's first take first column of matrix B and first row of matrix A. Now multiply 2 with 2, 0 with 1 and 1 with 1. and add them. So it will be 2 times 2 plus 0 times 1 plus 1 times 1. Similarly, now take second row for matrix A and do the same operation. So we will get 3 times 2 plus 1 times 1 plus 2 times 1. Now take the second column of matrix B and repeat the process again by multiplying 2 with 0, 0 with 1 and 1 with 3. So it will be 2 times 0 plus 0 times 1 plus 1 times 3. And similarly for the second row of matrix A, multiply 3 by 0, 1 by 1 and 2 by 3 and add them. So we will get 3 times 0 plus 1 times 1 plus 2 times 3, and we will get 4 plus 0 plus 1, 0 plus 0 plus 3, 6 plus 1 plus 2 and 0 plus 1 plus 6. Therefore, A times B will be 5397 of order 2 by 2. Now let's talk about multiplicative identity. That is, if we multiply an identity matrix with matrix A, then result will be matrix A itself. So if matrix A is equals to 2, 1, 3, 1, 1, 1, and identity matrix, we know that all diagonal parts are 1. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Matrix A is of order 2 by 3 and I is 3 by 3, and we can clearly see that our result should be of order 2 by 3. Now multiply A with I, we will get 2, 1, 3, 1, 1, 1 times 1, 0, 0, 0, 1, 0, 0, 0, 1. Now take first row of matrix A and first column of identity matrix and multiply 2 with 1, 1 with 0 and 3 with 0 and add them. So we will get 2 times 1 plus 0 plus 0. Similarly, take second row of A and multiply 1 with 1, 1 with 0, 1 with 0 and add them. We will get 1 plus 0 plus 0. Now take second and then third column of identity matrix and do the same operation again. So we will get 0 plus 1 plus 0 and 0 plus 1 times 1 plus 0, 0 plus 0 plus 3 times 1 and 0 plus 0 plus 1 times 1, which will give us 2, 1, 3, 1, 1, 1, and which is equal to A. Therefore, AI is equals to A. And our result is of order 2 times 3. Now transpose of matrix A, where we interchange rows and columns, and it is denoted by prime A. So if any matrix A is of the form Aij with order m times n, then its transpose will be Aj of order n times m. So columns will be row and row will be columns for transpose of A. Now let's take a matrix A, that is A11, A12, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Then its transpose will be, take the first row of A and write it down as a column for A transpose. Then take second row of A and write it down as the second column of A transpose. And then for third row, write it down as a third column. So it will be A11, A12, A13, A21, A22, A23, A31, A32, A33. Now let's take an example where A is equals to 1, 2, 3, 0, 1, 2, 1, 1, 1. Then its transpose will be, take first row and write it down as first column. Then take second row, write it down as second column, and for third row, write it down as third column. So we will get 1, 2, 3, 0, 1, 2, 1, 1, 1. So here rows of A is converted into columns of A transpose, or we can say columns of A transpose is rows of A now. Now transpose of a transpose matrix is a matrix itself. Now let's take a matrix 1, 2, 3, 0, 1, 2, 1, 1, 1. Then its transpose will be 1, 2, 3, 0, 1, 2, 1, 1, 1. Now the transpose of a transpose of A will be, now take the first row of A transpose and write it down as the first column, and similarly second row as second column, third row as third column, and it will give us transpose of transpose A, which is 1, 0, 0, 2, 1, 1, 3, 2, 1, and that is equal to matrix A. So therefore transpose of transpose A is equal A. Now this symmetric matrix. So matrix will be symmetric if they are in the form of A is equal to transpose of A. Then we can say that these matrices are symmetric. So let A is equal to 1, 2, 3, 2, 0, 4, 3, 4, 1. Then its transpose will be 1, 2, 3, 2, 0, 4, 3, 4, 1, which is again equal to A. So therefore here A is equals to transpose of A. So it is a symmetric matrix. Now skew symmetric matrix, and it happens when transpose of A is equal to negative of A. So let's take A as 0, 2, 3, minus 2, 0, 4, minus 3, minus 4, 0. Then its transpose will be, take first row and write it down as first column, then second row as second column, third row as third column, and we will get 0, 2, 3, minus 2, 0, 4, minus 3, minus 4, 0. Now if we take minus 1 common, then we will get 0, 2, 3, minus 2, 0, 4, minus 3, minus 4, 0. And that is equal to A. So we can write minus 1 times A. So therefore transpose of A is equals to negative A. So we can say that it is skew symmetric matrix. So if transpose of A is equals to A, then it is a symmetric matrix. And if transpose of A is equal to negative A, then it is skew symmetric matrix. So this was a quick review of matrix. Thanks for watching.